The thermodynamics is a branch of the physics that studies the effects of changes in temperature, pressure, and volume of a physical system, a material, a liquid, a set of bodies, etc., at a microscopic level. Matter is made up of different particles that move in a disorderly fashion. Thermodynamics studies the disordered movement.
These are the examples of applications of thermodynamics. First, we have as a reference the construction of buildings, especially when we talk about metal structures. In this case, the properties of the structures when they expand or contract with changes in the temperature of the environment must be considered. Now, moving on to the second point, we have as a topic the construction of thermal machines, such as car engines that use fuel, refrigerators that use the second law of thermodynamics, or the Clayton's statement that explain that it is impossible to build a cyclic machine whose only effect is the continuous transfer of energy from one object to another, of higher temperature without the input of energy by work. As a third example, we have the action of cooking with a pressure cooker, and we have as a risk and as a demonstration the fact that if the system is completely closed, there is a risk of explosion. And those are the most important examples where day-to-day and industry were mentioned.
The first law of thermodynamics states that energy is neither created nor destroyed, but it's conserved. So this law states that when a system undergoes a thermodynamic cycle, the heat given by the system will be equal to the work received by it and vice versa.
I will explain the formula of the first law of thermodynamics. This is the formula. Q is the heat exchange from the system to the environment. Its unit of measure is joule and calorie. Delta U is the change of internal energy of the system. Its unit of measure is joule. W is the work exchange from the system to the environment, and also its unit of measure is joule. The work can be positive or negative, but if the work is positive, the work is done by the system, right? But if the work is negative, the work is done toward the system, right? Like this. This is a piston, this is gas. This is work positive and this is work negative, right?
Well, hi, about the first law of thermodynamics, or the law of conservation of the energy. I'm going to do a very simple example. Well, when you move your hands with some velocity like this, you can feel some heat in the center of the action. And what that means, what is going on here? Well, the first law says that the energy can be created or destroyed, or it can change to one form to another. So in this case, you are changing the mechanical energy into the heat energy.
Well, I'm talking about the second law of thermodynamics. This second law can be expressed in several ways. The simplest being that heat will naturally flow from a hotter to a colder body. This heat is a property of thermodynamic systems called entropy. In the equations above, it's represented by S, and in loose terms, a measure of the amount of disorder within a system. Well, this is I read and investigated about the second law of thermodynamics.
The second law of thermodynamics is implicit in all the processes that occur in the universe. Entropy is always increasing, although it seems like it's decreasing. Rolling a dice has a higher entropy than tossing a coin in the air.
Thermodynamics has many uses in our daily life. For example, our refrigerator keeps the objects that we're going to consume at stable temperatures, which is an example to the second principle of the thermodynamics. It has many more uses, but all this leads us to the conclusion that is important part of our life because with which we live day by day and help us make our activities better and easier. But these have a disadvantage. Is that for the production of the objects that use the thermodynamics, there are large companies that produce contamination all around the world, but I think that with moderate use, it can be better and not produce a lot of contamination for the society.
Thanks for watching.